All right, so we're closing out 6.2, and we're going back to this example. I want to do one more like this just to reiterate and reemphasize what we talked about, reinforce. So it says determine which of the following probability experiments qualify as a binomial experiment. For those that can, or that are, excuse me, binomial experiments, identify the number of trials, probability of success, probability of failure, probability, and possible values of X. So we did A and B last class. Let's look at C. Yeah, I'm messing this ice cream up. All right, so let's do this real quick. All right, so according to a recent Harris poll, 28% of Americans state that chocolate is their favorite flavor. I meant favorite flavor of ice cream. Suppose a simple random sample of 10 is obtained, and the number of Americans who chose chocolate as their favorite ice cream flavor is recorded. So the first thing we have to establish is it a binomial probability experiment? Remember, it has 4 criteria that it has to fill. So first one, we're going to ask ourselves, are the, let's see, well, yeah, I can say, are the experiments performed a fixed number of times? And the answer is yes. And we're talking about 10 times. So the experiment is choosing a person, and that person being someone who chose chocolate, as their favorite ice cream or not. So are trials independent? The answer is yes. Someone liking chocolate ice cream has nothing to do with the other person liking chocolate ice cream or not liking chocolate ice cream. So that doesn't mess with the probability of choosing another. Are trials mutually exclusive? The answer is once again yes. You either like chocolate ice cream or you don't. It's impossible to like chocolate. It's not about liking chocolate ice cream. It's about your ice cream being a favorite flavor, chocolate ice cream being a favorite flavor. So you can't say that chocolate ice cream is your favorite flavor and vanilla is your favorite flavor. You know, favorite means that there's one that's above all. So that's why these trials are mutually exclusive. They don't have anything in common. Either chocolate is your favorite or chocolate is not your favorite. And then for probability for success is the same for each. And answer is yes. The probability of getting someone who chose chocolate as their favorite is 28%, and that's not going to change because you pick something. Because you pick someone who does like it versus not like it. All right. All right. All right. So this experiment is a binomial probability experiment because it meets each of the criteria. All right, so before we finish it off by labeling all of our pieces, any questions?
I got one.
Yep.
Sir, you said 28% of Americans.
Uh-huh.
Is that out of how many were polled? Does that matter?
No, that doesn't matter in this case. I mean, they said Americans, so we're assuming every American. I mean, you know, because they didn't
Okay.
really go that deep into it. What they would do in other ones wherein it will matter, and as we progress forward in different chapters, you will see that they will tell you out of the 500 Americans polled. You know what I mean? It will say it. In this case, that doesn't matter.
Okay. Thank you, sir.
Yep, no problem. All right, so N for us is going to be 10. That's the number of trials, and I'll label it like I did the last one. P is the probability of success. Probability of getting someone who actually chose chocolate as their favorite is 28%, so it'll be 0.28. 1 minus P, according to your complementary rule, complement rule, that will be those who do not choose chocolate as their favorite. So it's 72%. And the number of possibilities for X. So you always start with 0. In other words, there's a chance that when you choose 10 people, that you chose none of them. None of the ones you chose chocolate as their favorite. This is 1 choosing chocolate as a favorite, 2, and it goes all the way to 10. So from 0 to 10 will be your possibilities of X. 0 being no one you picked up randomly had chocolate as their favorite. 10 means you chose all 10 of the ones that you chose chocolate as their favorite. So X always represent the number of successes you ran. So all right, so questions before we look at the formula.
No.
All right. Now this formula right here, you can put it in your calculator. There are websites that people have used in the past that they felt was easier to use. So it's up to you. And which you didn't necessarily have to use the formula, you just had to use the numbers that was given in the problem. But as long as you have a legitimate way of getting the answer, and I don't have a problem with it. Um, all right, so here we have the binomial probability distribution function. So the probability of x is going to be NCX. Now that C is the combination formula. You're not going to plug in for C, but there is a combination option on your calculator. If you have a scientific calculator, wherein you can use that. We will not be plugging in a value for C. Once again, C represents the combination formula. So that's NCX. P to the X power. P is your probability of success. X is the number of successes that you achieved, times 1 minus P raised to the N minus X power. All right. So both this X right here and N minus X right here are exponents. All right. right, so I'll show you how to use the formula. And after that, we should be good to go.
For the day?
Yeah, man, because we did most of 6.2 last class, and this was the last thing in 6.2 that we needed to discuss. And 6.2 is the last section in chapter 6 that you're responsible for, just 6.1 and 6.2.
That's the front door.
Mhm. All right, so let's look at how we would use this. Where's my example? All right, here we go.
I do have a question about all the assignments. So all these calculators, are we able to use those during tests to get our answers?
Yep. Yep. Whatever you use throughout the year on your homework, on your take-home tests, then you are most definitely open to use that during the final test that's being proctored. I think it would be unfair to let you use it all semester, then take it away from you at the at the end, you know. So just make sure you have something reliable and something you're used to using, so you don't have any hiccups, you know, during that time. Better. All right, according to CTIA, 41% of all U.S. households are wireless only households. That means no landlines. In a random sample of 20 households, what is the probability that exactly 5 are wireless only? So if you choose 20 randomly, what's the probability of out of that 25 are wireless only? Okay, so first let's establish our variables and our givens. So probability of getting a household that is wireless only is going to be 41%. That's the first piece of information that they gave us. So it's 0.41. And that means the probability of not getting a household that's wireless only will be 1 minus 0.41, which is 0.59. All right. And so this is going to be our success. This will be our failure. And we know that because they want to know what's the probability of getting someone who's wireless only, and that's what that 41% represents. So that's going to be our success and failure. N, number of trials, is going to be 20. And X goes from 0 to N, which is 20. All right. All right, questions before we plug this stuff into that formula?
Nope.
All right. So we want to know the probability of getting exactly 5. So it's N, which is 20, C, X is 5 for us. Then that's going to be P, which is 0.41 raised to the X, which is 5. And 1 minus 0.41 raised to the, it was N minus 5. So that's 20 minus 5, and that should be it. So if I were going to put it in the calculator, I would do 20C. Now, some people actually have a calculator and they can put it in just like this. If you have that, then that's great. And some people may have to use this symbol for the 5, for your exponent. I'll go ahead and do 1 minus 0.41, which is 0.59, then raise it to 15. And this should, putting that in the calculator, 0.0656. So if you want to convert that to a fraction, not fraction, percent, I think my math lab is good with the decimal, but just throwing that out there. Questions on what we did there before we go to another one?
Yes, sir.
Mm-hmm.
Where did the 5 and the 15 come from?
Are you talking about the exponents? Or
Is that 5 times, is that 41 squared 5 times?
let me, are you talking about right here?
Yes.
Oh no, that's 0.41 times itself 5 times. So in other words, if I had 2 to the 5th power, that would be 2 times itself 5 times. So that's the
Okay.
same thing with 0.41. It'll be 41 times itself 5 times.
Okay, thank you.
Yep, no problem. And so that's why we want to use our calculator, because that 0.59 is raised to the 15th power. So we're looking at 0.59 times itself 15 times. All right. So just to interpret this right here, one way they may put the answer in my math lab, let's say in 100 trials.
They using the decimal.
Say again now?
It's using the decimal in my math lab.
Okay, cool. So they ask you for the interpretation. They may say something like this: in 100 trials of this study. All right, so just want to make sure we're okay with where they got this. If you were to saw this as an option for an interpretation, because that happens sometimes. They say this would interpret this way or whatever, and they give you like 4 options. So it says in 100 trials of this study. In other words, if we surveyed 20 households 100 different times. So if we were to pick 20 people 100 different times, we would expect 7 trials to result in 5 households that are wireless only. So that 7 came from them taking this number right here and multiplying it by 100. So, and I should have said about. I knew I left out a word. I think about 7. We would expect about 7 trials to result in 5 households that are wireless only. So they took this 100 and multiplied it times that 7. Not the 76.5. All right, let's look at B. So it says fewer than 3 are wireless only. So you're talking about the probability of X being less than 3. So 3 is not included. We're talking about fewer than 3. So we want to know the probability of 0 or 1 or 2. So what we would do is find the probability of 0, add it to the probability of 1, add to the probability of getting 2. All right, so we would take each one of those, 0, 1, and 2, and plug it into the formula individually. So we're looking at 20C0. See if I can get it all in one line. 0.1 raised to the 0 power to the 20 minus 0. Nah, I'm not gonna get all this in one line. All right, and then do the same thing for 2. All right, so you have to plug in the formula with X being 0, plug in the formula with X being 1, and plug in the formula with X being 2. And we have 0.00026, 0.00363, 0.02397. So adding them together, got 0.0028 as a probability. All right. Questions, questions, questions.
Nope.
Mhm. And like I said, and maybe I'll show you next class. I have to look for it. There are formulas, not formulas, websites out here. If you just Google probability, binomial probability distribution function, they have things you can plug in which all you would do is type in this right here, and it would give you this. Once you put in the numbers like 20, 0.41, 0.59, and all the good stuff like that, whatever they ask for. So, yep. But outside of that, you can always just calculate it with your calculator if you know how to use it properly.
And I don't.
So yeah, so I think we're supposed to be getting up soon, so we'll try to make sure we get you straight on that. All right, so this one says at least 3 are wireless only. So he's saying at least 3, that means the smallest is 3. So we're looking at x being greater than or equal to 3. So that means we want the probability of 3 or 4 or 5 ... all the way up to 20. So that's means we have to do each one of them individually. Up to 20. Or we can recognize that we just calculated x is less than 3. So everything else would work for us. So we can use the complement rule. So the one we just calculated was everything less than 3. The one we're trying to calculate is 3 and greater. So what we can do is take the probability of everything less than 3, subtract it from 1, and we will have that probability. Now, if we hadn't calculated everything less than 3 in the previous example, then we would be in a position in which we would have to find 3, find 4, 5, 6, 7, all the way up to 20, and then add them together. But that's when, if you were to have something like that, that's when having an Apple website that would actually be beneficial for us. All right. Questions before we look at this last one? All right, so the number of households that are wireless only is between 5 and 7 inclusive. So that means we include 5 and the 7. So we're looking at this. So there's 5 or 6 or 7. 5, 6, and 7. So I want to get all 3 of those. And we plug each one of those into the formula.
I'm trying to make it sound.
And of course, you know, once we already established that 1 minus 41 was 0.59, you can use that there. I'm just, you know, plugging it into the formula. So there's no issues with where this stuff is coming from. All right, so those are our 3 pieces. 25.415 to the 5th power minus 20 minus 5, yep. 6, yep, okay. So making sure I got my stuff right. And then from there, go ahead and get your 3 pieces. It's 0.0656 plus 0.1140 plus 0.1585. And we get 0.3381. All right. Questions. Say that again, man.
No questions.
All right. Sounds good. All right. So, yes, I don't need to, yep. So as I mentioned, just reiterating what was said previous, this is test 3, and on test 3 we have 5-1 through 5-4, 6-1 through 6-2. All right, so next class will be open for questions. So make sure you check out that review, see if you have any questions on anything. Do we need a review day? What y'all think? We need a review day? Next class? So is that...
Yes.
Yes.
I was like, okay, well, I guess y'all want to go to chapter 7, y'all. Nobody said anything. Okay, so next class we won't do anything new. It'll be strictly
Thank
reserved for strictly reserved for questions. If you don't have any, then that's fine as well. I will not do anything new, regardless of the outcome. So yeah, so check out that. If nothing else, look at the test review. And when I say review, you know, we've done 6 chapters up to this point. Anything that you have questions on up to the 6 chapters, you know, feel free to ask. And we will go from there. Questions, concerns, comments on anything
Nope.
before we
See you
close
tomorrow
out?
at 11.
I will see you, ma'am.
Yes, sir.
Yes.
If I could get with you sometime, I don't know. Homework 5-4, number 5 is just giving me fits.
Okay, let's see. We got a few minutes. Let's see what's going on there.
It's not a long.
Let me see if I can pull it up real quick.
Yeah, sorry about that.
Oh, no, it's no problem.
And you're not the only one. I'm struggling with that one too.
And thank you.
Oh, yeah, no problem. Where's my stuff? Oh, yeah. All right, you said 5, 4. Number 5, is this the one?
Yes, sir.
All right, so let's see. In a recent poll, a random sample of adults in some country was asked when you see that's a product made in our country, more likely bad. That's likely bad. Either. Okay. Okay. See, nope. All right. What is the probability that a randomly selected individual is at least 55 years of age? All right. Given the individual is more likely to probably emphasize major country. All right. So we got at least, and I'm just writing down stuff real quick. 55 given. All right. So, well, let me write down these numbers. Let my phone at. Take a picture so I don't have to come back.
16 and 75 that we use.
Well, let me take a picture of this and then I'm gonna come back to it so I don't have to keep coming back to these numbers. And then because I haven't even looked at the numbers, I was looking at the problem. So let's write down what it's asking us. For this first one, it says at least, no, go black. At least 55 given, it should be P in front of it, given it's more likely, no, I'm just scribbling that, more likely to choose made in America, whatever that was. All right. So what I need up top is the probability, oh, we're dealing with numbers, hold up. Yeah, we're looking at numbers, so the number of being at least 55 and more likely to choose. Then on bottom, I need the number of those who are more likely to choose. All right. So as always, when you're looking at your numbers or the probability, you always on top is going to be both of them. What category fits both of them? And then on bottom is this one right here. Whatever comes after given, that's the one that will be on bottom. So the number that is at least 55, no, at least 55 and more likely is 404. And the number of people that's more likely is 1244. So remember that that's going to be a total. So that comes from your total column. And then, like I said, the 404 came from the 55 plus and the more likely. So it's around the 3 decimal places. 404 divided by 1244, 0.325. So I'm gonna go plug that in, make sure I'm good to go. Yep, got my green check. All right, so are we good on that one before we look at the next one that they're asking about? Did that make sense?
Yes, sir.
Okay, cool. So now B says, what is the probability that a randomly selected individual was more likely to buy a product, emphasize made in our country, given? So the first part, let's go back. Oh, I gotta share it. So this time we want the probability of someone more likely to choose, and it says given. That line always represents given for us. The individual is at least 55 years of age. At least 55. So the number up top is going to pretty much be that same 404. Talk about the number of people that are more likely and at least 55. And then on bottom, whatever this one is, will be down here, the number of at least 55. But once again, talking about the total number of people that they have that's at least 55. Nope, I'm gonna stay with the red. So that number that's, go back to my picture. So that, well, we already knew this one. Being more likely to choose and is at least 55 is at 404. Then the total number of at least 55-year-olds is 569. So now we'll divide those out. That's going to be 0.710. No, they asked for 3 decimal places.
When they ask for 3 decimal places
Mm-hmm.
and say behind that 0 would be a 5 or a 9,
Mm-hmm.
the fourth one, do we put a 1?
All right, so just make sure I'm with you on what you're saying. So if we had a 5 right here,
Yes.
yep, it would be 0.71. Oh, yeah, 711.
Okay,
Yep.
thank you.
Yep, no problem. All right. So does that answer your questions about
Yes.
that?
I love you. Thank you.
All right, no problem, sir. As always, I love you too, man.
Okay.
All right. So if you
And
we need to meet outside of that, outside, another time, just let me know, shoot me an email and we can talk about it. Any other problems?
Thank you.
Yep, not a problem. Have a good one.
You too.
see you tomorrow.
All right, take care, lady.